That's pretty crazy, dude. Dude, Shannon, are you seeing this?
Okay. So, with that strobe light, if you hit that frequency just right, there you go, that's the place out there. So it looks like it's standing still. But what's happening is that light is flashing at the same point every time in that wave. So what this could represent, as this goes along, and that's very long. Okay. So what you saw was that when I was able to freeze frame that, you were flashing at the same point every time, and your brain, the reason that to you it looks like it's standing still, and this is what we're talking about, your brain basically has a very short-term flash memory. And your brain was saying, oh, it looks like it's in the same point every time. So if that's what you saw, you would think, oh, it's just this kind of weird wave in the string. It's still vibrating. Your brain just thinks it's like, oh, it's appearing at the same point every time. And that's why to you it looks like it's a solid wave going through like this. So again, with this one, if you look at what you had, okay, so go turn those front, actually turn on all the lights. Beautiful. Okay. So we turn this on. So how many antinodes does this have? Three. 1, 2, 3. Okay? So the antinodes have that maximum velocity. So this would be like 1.5 wavelength. Now, if we change the system, so that was like a 200 gram mass. So now we'll put a 500 gram mass on there. So if I put a 500 gram mass on there, what's happened to the tension? Tension's gone up. So now when I turn that on, I might have so much tension I can't get it through. Okay, so with this one pretty much is that first harmonic. So it's second harmonic. So you've got the wave coming up like this, and then it's coming back down like this. So by changing the tension in the spring, even though the exact same spring, now that standing wave has a different set of conditions. So did I change the mass per unit length of the string? No. But what I did do was increase tension. Now, I went from having basically 1.5 wavelengths in there to the 1 wavelength. So when I went from the 1.5 to 1, I made the wavelength bigger. Okay? So what had to happen to the frequency then? So when I went from 1.5 to basically just having 1 wavelength in there, the wavelength became longer, right? Because it went from having 1.5 wavelengths in here to just 1 wavelength. So the wavelength became longer. So the wavelength became longer, and notice I had to crank that up. I had to have a higher frequency. Okay? Why did I have to have a higher frequency? Because, well, what happened to the tension in the string? Tension went way up, right?
That means I had to go faster.
Yes.
That means you need more frequency.
Yes.
Right?
Okay? Exactly. Because I made the tension higher. Because if you look at that, V equals the square root of tension over mass per unit of length. The mass per unit of length in the string stayed the same. So I increased the tension. So if I increase the tension, what's going to happen to the velocity? Velocity got bigger. Okay? So since the velocity got bigger and the wavelength got longer, therefore to create a higher velocity, I had to have a higher frequency. Okay? Got it? Got this visual. Okay. Back we go.